Unmute. Very good evening, all the participants. We'll start the event in a few minutes.
Hello.
Yes, sir, it is audible, sir.
Okay. So I have joined.
Yes,
Okay.
Yeah, thank you.
Thank you.
Thanks, sir. Thank you. I can go.
Yeah, very good evening to one and all. We'll start the session.
Good evening, sir.
A very good evening to all of you. So I am Dr. Manyam Taili, working as Associate Professor. I feel privileged to welcome you all on the behalf of Management, Principal, Department of CSE and Emerging, Mallareddy Engineering College to the 2-week faculty development program on impact of artificial intelligence in the field of agriculture, sponsored by AICTE Training Learning Academy. It is a virtual platform that has provides us the environment to connect with each other. So for the successful conduction of the program, let us take blessing of the Almighty by the virtual lamp lighting with Saraswati Vandana program. Meghana, so start the prayer song.
Yes,
For the
sir.
students. Yeah.
ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು ವಿದ್ಯ ಪ್ರದಾಯಕ ಶರಣು ಪಾರ್ವತಿ ತನಯ ಮೂರ್ತಿ ಶರಣು ಮೂಷಿಕ ವಾಹನ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ನಿಟಿಲ ನೇತ್ರನ ದೇವಿ ಸುತನೆ ನಾಗಯಜ್ಞೋಪವೀತನೆ ನಿಟಿಲ ನೇತ್ರನ ದೇವಿ ಸುತನೆ ನಾಗಯಜ್ಞೋಪವೀತನೆ ತಟಿಲ ತಾಂಕಿತ ಕೋಮಲಾಂಗನೆ ಕರ್ಣಕುಂಡಲ ಧಾರಣೆ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು ವಿದ್ಯ ಪ್ರದಾಯಕ ಶರಣು ಪಾರ್ವತಿ ತನಯ ಮೂರ್ತಿ ಶರಣು ಮೂಷಿಕ ವಾಹನ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ಕುಕ್ಷಿಮಹಲಂಬೋಧರಣೆ ಇಕ್ಷುಚಾಪಲಗಿರಿಗನೆ ಕುಕ್ಷಿಮಹಲಂಬೋಧರಣೆ ಇಕ್ಷುಚಾಪಲಗಿರಿಗನೆ ಪಕ್ಷಿವಾಹನ ಶ್ರೀ ಪುರಂದರ ವಿಠಲನ ನಿಜ ದಾಸನೆ ಪಕ್ಷಿವಾಹನ ಶ್ರೀ ಪುರಂದರ ವಿಠಲನ ನಿಜ ದಾಸನೆ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು ವಿದ್ಯ ಪ್ರದಾಯಕ ಶರಣು ಪಾರ್ವತಿ ತನಯ ಮೂರ್ತಿ ಶರಣು ಮೂಷಿಕ ವಾಹನ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ. ಥ್ಯಾಂಕ್ ಯು.
Uday Bhaskar. The problem. Okay. No, look at it.
So now I would like to give some introduction about FDP. First of all, sincere thanks for the AICT Academy to approve our FDP proposal. So our title is Impact of Artificial Intelligence in the Field of Agriculture. It is 2-week program. The first week is in online mode, which start from 17th October to 22. Followed by second week is in offline mode, which start from 25th October to 29th. The motivation for proposing the FDP is to understand the artificial technologies in the field of agriculture. Now our objective, explore the knowledge of emerging technologies like AI, MI, and deep learning to understand the applications of emerging technologies in the field of agriculture. Now this is our schedule online program details. In day 1, Dr. Mahesh Kumar H. Kolekar is going to talk on deep learning techniques for agriculture applications. In day 2, Omkar Ramakrishna Tadem is going to talk on introduction to artificial intelligence and machine learning. In day 3, Dr. J. Somshekar is going to talk on artificial intelligence in the agriculture sector, applications, case studies, research directions. In day 4, Pradeep HK is going to talk on AI, ML techniques for soil and water resource management. And in day 5, Dr. S. Manjunathan is going to talk on deep learning for precision agriculture. In day 6, Prabhudeva Jagadish is going to talk on IoT technology for precision agriculture. Now offline program details. In 25th, ML Sai Kumar is working on time and stress management. In afternoon session, we have the travel visit for the Ikrisat Patancher. Now in day 8, introduction to AI, ML tools answered by Omkar Ramakrishna Tadem. And in afternoon, is going to talk on the plant decision identification using deep learning. In day 9, S. Iswanath Raj is going to talk on new education policy 2020. Now in the afternoon session, Mukesh Perimula is going to talk on the artificial intelligence for crop gene expression. Now in day 10, T. Damodar Reddy is going to talk on agriculture situation in past, present, condition and role of farmers. And in the afternoon session, Dr. G. Rekha Madam is going to talk on intelligent crop recommendation system using machine learning algorithms. In day 9, Dr. Bharat Kumar from IIT Tirupati is going to talk on Indian values, ethos, classroom conduct and behavior, teaching, learning, psychology. So now I would like to request A. Rasagna Madam, please read the profile of the beloved principal.
Sir, is my voice audible, sir?
Yes.
Thank you, sir. Sir, good evening, everyone. I am Rasagna, working as assistant professor in the Department of Computer Science and Engineering. I feel privileged and honored to give an introduction about our principal, sir, Dr. A. Ramaswamy Reddy, sir. He is a principal and professor of CSE department at Mallareddy Engineering College. He obtained his PhD from JNTUK Kakinada in the Faculty of Computer Science and Engineering. He has 20 plus years of experience in teaching and research. He worked at various capacities like principal, dean, head, controller of examiner, and chief warder at reputed engineering colleges. He is well versed in sophisticated research techniques and technologies, applications of image processing, data mining, and machine learning techniques. He also possesses excellent knowledge and skill of various programming languages and expertise in lab and research, data collection analysis. He has guided over 200 BTech students, 50 MTech students, and currently 5 PhD students are working under his supervision. Dr. A. Ramaswamy Reddy Garu has published in more than 25 refereed international journals and presented papers in many national and international conferences. He has given over 30 guest lecturers seminars, organized around 20 workshops, conferences, guest lecturers, and attended as a resource person for organizing workshops outside. He is a member of many societies like ACM, IEEE, ISTE, Life Membership, FIE. Thank you, sir.
Now I would like to request Principal Sir to address the gathering.
My name okay na?
Okay, sir. Okay, sir. Audible, sir.
So respected chief guest of this FDP program, Dr. Chundari Sarda, principal scientist, Indian Institute of Oil Seeds Research, Hyderabad. And today's speaker of this FDP program, Dr. Mahesh Kumar H. Collector, Associate Professor at Triple Department, IIT Patna. My dear HOD, faculty, and the participants of the various colleges. So good evening to everybody, and a hearty welcome to 2 weeks FDP program in our college conducted by the Department of Computer Science. So first of all, my sincere thanks to the chief guest of the today's FDP program and all resource persons immediately accepting our invitation for giving lectures in this FDP program. And also, I really appreciate Department of HOD of CSE and the faculty for conducting this FDP program in the Department of CSE. So nearly, I think last FDP meeting conducted by the ASCD Delhi. I am also attended this program. At the time they launched all the programs. So they announced the FDP, so which college sanctioned from the ASCD. So nearly 4,500 proposals received from the various institutions in entire India. So out of that, only in the first phase, 250 FDPs finally they selected and sanctioned to all engineering colleges. So especially in Telangana state, in the Hyderabad location, I think very few colleges, only 2 more colleges got this FDP programs. Last academic year, many colleges got the FDP programs, but this academic year, due to lack of the funds, so and also strictly evaluated. I think 3 levels of the evaluation conducted by the expert people this academic year. So that is the reason I think some of very few institutions they got the FDPs in this academic year. So only 250 institutions got it. So out of that, in only 2 colleges, I think MREC, Malad Engineering College main campus, and one of the college, another college, Hyderabad, CVIT, Triple Department, one of the professor was got this FDP program. We are very happy. So conducting this FD program in our college. So coming to our college side, so this college, MRS Malad Engineering College, was established in academic year 2002 with intake of 240. Now the present intake is 1800, 1620 UG and 180 PG, 180 PG programs we are offering. 1620 plus 180 total 1800 we are offering in our college. So 3 times accredited by NBA and NAC and autonomous. Only one of the institutions in Telangana, Andhra. So 3 times autonomous, 3 times NAC, 3 times NBA accreditation. Only one of the institutions, that is MREC. So now this college is also eligible for the deemed to be university. Next academic year, definitely we are also going for the deemed to be university. This institution also having the excellent achievements. NAC AW plus with 7 years. So in Telangana and Andhra, only one of the institutions, that is Malad Engineering College. We got first rank and South India 6th rank regarding NAC. All India 11th rank we received. So regarding NBA accreditation also 3 plus 3, 6 years. 3 plus 3. Actually, NBA accreditation are directly giving 3 years. So based on our all UG programs in our college, all UG programs, 5 UG programs, we got more than 700 plus 4. More than 700 plus 4. All the departments we got it. So that is the reason. So NBA people, expert people also recommended to our college 3 plus 3, 6 years. So this is only one of the institutions in entire India. That is also great achievements. This college also having the NRF ranking 201 band. So we are expecting this academic year definitely good rank. So this college also having the MIC star rating. MIC due to pandemic last academic year, highest rating given by the Minister of Education 4-star. Out of 4-star we achieve it. So this college also having the RA ranking, and also AICT nodal center we are also having. ISRO nodal center also we are having. Excellent center of excellence facilities also we are having. So business incubation center also having. So this academic year, one of our student, first year CS student, got the 15 lakhs fund from the MSME people. So the two more students from EC department and CSE students. They also till now we are not received the amount, but outside people or private people, they are ready to investing nearly 1 crore rupee based on their ideas. That is also great achievements. So this college also having the official both wings. So NCC regarding NCC Army wing and Air Force wing. So recently we also conducted the NCC Army wing completed in the last 15 days back. Air Force wing also it will come. Officially we are receiving receiving the letter also. That is also great achievements in all aspects. So now our college is going in the right direction. So this is totally total credit goes to our faculty members, teaching and non-teaching faculty members. So that is also great achievements. Regarding placements also for last 3 academic years. So in all aspects, the highest package the last academic year 56.7. Nearly 96.7% of the students they are placed in various MNC companies. Highest package is 56.7. Next highest package 30 lakhs, 26, 25, 24, 22, 20.8 to 20 lakhs, 15 lakhs. So 20 lakhs and above, nearly 48 students are selected in various MNC companies. So on 10 lakhs or nearly 77 students, 15 lakhs, 99 students. And 6 to 8.5, nearly 670 students are there. That is also great achievement. So now we are in the right direction. We are very happy. So in MRSC, so every semester, every department, we are conducting at least one FDP program. That is mandatory by the MRSC. Okay. And 2 conferences and 2 seminars also we are conducting. So that is also great achievement. Next, so in all aspects, so this academic year also, nearly 4 departments they conducted the FDP program. So now Atal FDP program today we are conducting. It is very happy, and also congratulations to HOD of CSC and the coordinator of this one. Right. So this is the brief information about our college. So and also I request all the participants, not only our college, outside participants also participating in this activity. So this is the latest technology. Technology also day-to-day changing. So I request all the faculty, updation is very, very important. Okay, that is also more useful to you, not only you, and also more useful to the students also. I request all the participants, please utilize effectively, and giving final day, I'm expecting at least 4 to 5 participants. So please give your valuable feedback in the valedictory function. Valedictory function I'm also expecting. Right. So once again, I sincere thanks to Chief Guest Tunduri Sarada Madam and today's speaker Mahesh Kumar Echkalkar participating in this FDP program. So thank you one another.
Thank you, sir, your valuable information, supporting and encouragement. Sir, please accept our token of appreciation. Sir, Principal, sir, please accept our token of appreciation, sir.
Okay.
Next, I would like to request Rasagna Madam, please read the profile of the chief guest, Dr. Chunduri Sharada Madam.
Okay, sir. Hello, ma'am. I'm privileged to introduce you. Dr. Chunduri Sharada is working as principal scientist at Indian Institute of Oilseeds Research, Rajendra Nagar, Hyderabad. She obtained her PhD in agriculture statistics. She has excellent experience in research. She has done various projects like develop castor core collection, different oilseed crops, managing diseases and insects in oilseed crops through large image analysis and artificial intelligence. Areas of interest are statistical modeling, multivariate analysis, bioinformatics, image analysis, machine learning, and deep learning models. Dr. Chunduri Sharada Garu has published more than 13 refereed international journals and presented papers in many international and national conferences. Thank you, ma'am.
Thank you, Rasagna Madam. Now I would like to request Chief Guest Dr. Chunduri Sharada Madam, give some words on FDP.
Thank you. Am I audible?
Yes, madam, audible.
Yes,
Good
ma'am.
morning, one and all.
Good
Good
evening,
evening, one and
Good evening, madam.
At the outset, I would like to thank Ramaswamy garu, principal, and Manyam, coordinator of this training program. I honor and privilege to give some of my thoughts, AI and impact of AI agriculture, and before going to my actual talk, it's my prime to introduce my organization. I'm working in Indian Council of Agriculture Research. Its organization is all across the country. There are one institutes across the country. Seven state agriculture university also come under Indian Council of Agriculture Research. And I am working in Indian Institute of Oilseeds Research. We deal with the oilseed like flour, safflower, castor, linseed, sesame, rice. All these oil related research of these oilseeds will be dealing. Similarly, we have 6 other institutes in Hyderabad, like Millets Research Institute here, and Rice Research Institute, Powder, and there is a research institute, Dryland Agriculture, and one more, there is a meat institute in Hyderabad. One more is there academy for natural as a natural agriculture training of scientists in that is also in Hyderabad. This is brief about my institute and my organization. And coming to the AI and impact of AI in agriculture, if we see our population around 5 billion, and it will increase to 9.7 billions in 2050. But the rate we are, what is our food production? We need to produce to feed those additional 2 billion people, 60%. So much improvement we have to in our farming system. Can assess based on this. So, but within span 30 years, not achieve like 6% of traditional food production. So the traditional this, but so agriculture you used to look around what waste and meat to improve our agriculture production. One of the best this thing is digital transformation AI. So you see, in agriculture there is from you name every process of the agriculture you can apply artificial intelligence to improve the process by saving time and economy and improving the livelihood of the farmer. 70% of farmers are population is rely on the farming, and most of them are small and marginal farmers. These small and farmers means they are having only less than 1 land holding. So we differ from other geographic other countries. We having very small holdings. So we have to address these small holdings, and we have to hold small farmers to improve their production productivity capacity by using this artificial intelligence or I drone technologies and all. But if you say agriculture, I am like from seed to harvest, in every process we can apply the artificial intelligence. For example, in the beginning of the seed selection, if you that seed selection based on analysis, deep learning models can predict the whether that seed is fake or the pure for the crop. So if they sow the crop with the seeds, they won't germinate. They will come to the field there. will has to pay losses. Um, so from the seed, and if after sowing the seed and there is weed menace everywhere, it is a ours is a mostly fed agriculture. It depends on rain. So there is always a minimum input. So always there is a problem at every stage of the crop culture. Like if you uh, crops, the weeds are with that means the unwanted plant apart from crops. Rice crop you growing, seed is which like other grasses, um, other plants which are not crop, that's called weed. So this weed also has so much of message to improve the yield. So that all, and we can identify by taking the pictures with them, and those images will has process and use deep learning models. We can identify what are the weeds, what are the rice plant, and that help the farmers to improve their enhance the yields. And if we're coming from the like flowering stage or with crop growth evolved, we having so much enhance of the pest diseases. So more 50 to 20% of losses are because of the pests, and there are a lot of pests and diseases for each crop addressed. Such the farmer still are unaware of such pests and diseases, able to manage what control measures have to take, and unable to identify which is the pest or disease has occurred on their crop. Diseases, thousands of leaf diseases in the crops. So to identify that what leaf diseases, this artificial intelligence can be utilized by using the computer vision, artificial and deep learning models. So so in every stage of the or every stage of the cultivation practice, there is an opportunity to improve, to include our AI, some give effect for the um, to increase yield activity, and ultimately the farmer will benefit, they will improve their livelihood. So in every aspect of agriculture process, you can apply artificial intelligence. Similarly, now in the farm field side, even in that there is lot of data has been collected, even in bioinformatics or say in with the satellite images, field crop yield prediction, the DNA level, what is upregulating genes or downregulating genes for disease. Such sort of huge data has been will be collected in the agricultural research. So there also for predicting the disease, not only predicting the diseases, proteins, or at informatics or at macro level for improving the yields and all, the can be utilized. And apart from that, if you see the policy aspects of the agriculture, that are there also that can be applied like if they like using climate change in scenario, could be the crop in 30 years, what could be the crop yield after 50 years, what carrying capacity of that yield capacity, like how much rice can be grown maybe after 50 years when it reaches carrying capacity. Such studies are be done machine learning, artificial intelligence. Like, but have the opportunity to apply our artificial intelligence in every aspect of culture. The major concept is building the data. We have to collect data in such manner so that we apply our any AI or ML techniques, it should give proper results. So proper data collection, making a data collection ecosystem is very much important. Apart from analysis, so how to interact the mainly agricultural experts, and experts, we make a need assessment what the farmer need, what the stakeholder like policy, what they is expecting us, what data we have to collect and how to collect, how frequently we have to collect, and what are the precautions taken. So data collection is the most crucial part. Otherwise, in a situation of garbage in, garbage out. You can apply any number of model data, but if it's not giving any decision to a policymaker or to reach farmers, it will be wasted. I suggest the first you are going proposing you thoroughly discuss what is the need of that with the subject matter expert, and what is the data to be collected, how it be collected, and being in graduates, you may not be in the agriculture, but you discuss deeply with subject matter experts, you will come to know where what they want, and what are aspects, what terminology in the agriculture will be um, will be done by discussing subject matter experts. And after plan data collection, after collection the data, and you have to the application, they also need great effort to get the more accurate, the more precise results, should lead a pro application reach to the farmers. Here problem is there are you can see artificial intelligence images, tons of paper, disease and pest protection, but the ultimate goal is reaching. After researchers um, they are working diseases find the output is not to the farmers, so it should make an application and reach to the farmers. And whatever application we should make, it should be scalable, sustainable, and ethical. Then only the purpose of your research will be fulfilled, and we'll have a great satisfaction. Okay, we have done something for the simple lesson, disease classification and prediction, and the making application, we can increase 5 to 6% of the yield. That itself is a achievement for scientists of artificial intelligence. So I just all you people to have greater interaction with your subject matter in experts, and um, proper planning of the proper collection of the data, up for instrument techniques, and you you that it should to the stakeholder, whether it's a farmer, researcher, or other policy maker, that will be utilized. Then only will the impact of AI in the agriculture. And it is a aspect because we are having dynamic agriculture system in our India, and we're very having a small hold. So maybe may have to focus regional specific actions, or even sometimes we have to focus the village level. What sort of dynamics are active in the agriculture? So you have the proper discussions and have the knowledge before your research project. Thank you.
Thank you, madam, very much kind your informative knowledge. Hello. Hello.
Manyam sir, you are audible.
Hello. Rasagna madam.
Yes, sir.
So please give vote of thanks.
Directly vote of thanks, sir.
Yes, give the vote of thanks for inaugural session. So we will
Okay.
start immediately session.
Okay.
Start the session. Give the vote of thanks, Rasagna.
Yes, I would like to thank our honorable chief guest, Dr. Chunduri Sarada ma'am, for giving an informative message and informative session, and it is very catchy to all the participants. Thank you, ma'am. Thank you for your wonderful words. So should I call next speaker, sir? Mandam sir, should I call speaker, sir?
Yes, I'm audible.
Yes, sir, you're audible, sir.
Okay, now I would like to request Rasagna madam, please.
Yes, sir. Thank you, sir.
With the
So now I would like to call upon the speaker of a complete session, Dr. Mahesh Kumar H. Kolekar. He's Associate Professor of EEE at IIT Patna. He obtained his PhD from IIT Kharagpur and also received postdoctoral fellowship from the Department of Computer Science, University of Missouri, Columbia, USA. He has knowledgeable experience in teaching and research. He worked at various posts like head of the department, chief warden, and PhD coordinator. He has guided BTech students, MTech students, and PhD students. Dr. Mahesh Kumar H. Kolekar Garu has published more than 68 referred international journals and presented papers in many national and international conferences. He has given invited talks, lectures, seminars organized around workshops, conferences, guest lectures, and attended as a resource person for organizing workshops outside. He is a member of many societies like IEEE, IST, Life Membership of CSI. Thank you, sir.
So thank you, Rasagna. Sir, so please record the session, sir.
Hello.
Yes, sir, you are audible, sir.
Okay. So I am going to share my PPT and then I will start the session. Okay.
Okay, sir.
Okay. So PPTs are visible? Hello.
Yes, sir. Yes, sir, it is visible, sir.
Yes,
Okay.
sir.
So what I decided in the first session, I will explain deep learning and its architecture, and then we'll have a break, and then we'll discuss its application for agriculture domain. Okay. So this is I have written my introduction also, that I did postdoc from University of Missouri, USA, and this year also I'm selected as a top 2% scientist of artificial intelligence and image processing area. This is my mobile number. You can call me, okay, if required. So in this session, I will talk about the deep learning, the introduction, then how this is different or a relation between AI and ML, And then mainly we'll discuss convolutional neural network and convolutional layers. Actually, they are contributing much, and they are very popular about the feature extraction task as compared to machine learning. We'll discuss some aspect like loss function, regularization, ResNet. Since this is a very first talk of your FDP, it's good to start with some basics of the deep learning, and then we'll come to the applications. So for this deep learning area, you should require some knowledge of linear algebra, calculus, some probability and optimization. These are some topics from mathematics you should study actually, okay, if you want to go deep into this deep learning area. And this deep learning area has also close association with computer vision because and image processing area, because these deep learning techniques you hold basically for object detection task. Okay. And artificial learning is a big domain. Machine learning is a subset of AI, and then again a deep learning is a subset of machine learning. Okay. So if you are using machine learning, then in machine learning there was one algorithm called as artificial neural network. So people work on that ANN model. They introduce many layers, actually hidden layers into the ANN, and that area become very popular, and now we are calling it as a deep learning. Okay, here basically there are two types of learning approaches. One is a supervised learning and unsupervised learning. As name indicates, supervised learning contains the supervisor is present there, and unsupervised learning means without supervisor, model will learn through experience. Okay, so we are going to see all those aspects. Okay, so this field of computer vision was evolved in past few years due to the deep learning technique, and there are mainly two reasons for that. One is the availability of labeled image data set with million of image and computer hardware that allow to speed up the computation. So I would like to mention that AI area was there actually even 1980s also. This area was introduced, but it was not popular because for this training purpose we require a large number of computations, okay, and high speed processors. So because of the development in the hardware, now this area is becoming popular. And secondly, even though we have a very good hardware, there was no any standard data set for comparison purpose or for some. So in 2011, one data set was introduced, and that data set name is ImageNet data set. Okay, so in 2011, this ImageNet data set was introduced and was made available for publicly available. This ImageNet data set contains millions of images, 40,000 millions of images, and 1,000 classes, actually 1,000 different classes, means few images of the car, then bus, image of the face, then image of the tree, etc. Such a 1,000 classes are there in this ImageNet dataset. And so everybody started actually testing their algorithms on this dataset, and that's why there is one standard dataset for comparison purpose. And they conducted a competition every year since 2011, and every year people come up with best model. Actually, they used to award the best performing model, and that's way this area progressed. Okay, because of that challenge. Okay, so this is some little history I mentioned. This I already mentioned that deep learning is a subset of machine learning, and machine learning is a subset of AI. Okay, so today we are going to focus mainly on the deep learning. After years of intensive investigation, a few models matured and become important tool, and one of them is a convolutional neural network. This is very, very popular actually, and people have used extensively this model for various applications. So this deep learning becomes now interdisciplinary actually, based on the application in the civil engineering, mechanical engineering, biomedical engineering. Okay, so people are using these deep learning techniques. And convolutional neural network, as name indicates, it is based on the convolution operation actually. Okay, in electronics engineering, actually in second year there is one course called Signals and Systems, where students study convolution operation, how two signals can be convolved actually. And convolution theorem says that convolution in the time domain is equivalent to the multiplication in the frequency domain or Fourier domain. So based on that, actually, that concept, this area developed actually. Okay, and people are using this convolutional neural network or the layers of convolutional neural network for extracting the features automatically. So that is the difference between machine learning and deep learning. In machine learning, you have to extract the features first, and then you will apply the classifier to classify, okay, given data. But in deep learning, this feature extraction is not required actually. Okay, so it is done automatically by using the convolutional layer. So these things we will discuss in forthcoming slides. Okay, so this is the Venn diagram. Artificial intelligence is a big domain, then machine learning, and then deep learning. So we are focusing on this deep learning. Okay, so performance wise also we can compare that machine learning was existing actually before deep learning. So many algorithms were developed in the machine learning domain, like a binary tree, random forest, then artificial neural network, support vector machine. Such a many classifiers are there. So out of that, artificial neural network is one classifier which people developed actually by introducing many layers, many large number of hidden layers, and that is called as a deep neural network actually. So that's why deep neural network is a subset of the machine learning or machine algorithms. So you can see, if your data set is small, then most of time people will go for the machine learning approaches. They will work better. But if data is big actually, then you can go with the deep learning. So deep learning demands a data actually. These are the data hungry algorithms. Okay, and so in this way you can decide actually whether you will use a machine learning algorithms or deep learning algorithm. Okay, so data is one of the big challenge, large number of data, and that's why after introduction of the ImageNet, big data set publicly available for everybody's application or a reference purpose. So that's why this area developed. Okay. So as I mentioned, this convolutional neural network is very popular, and so those convolutional layers are used for extracting the features, or otherwise we have to use a special features like a special domain feature or frequency domain feature like energy, entropy, so many features people used to extract actually, machine learning algorithm, and they have to even decide actually which features are good, which are bad. Okay, so there was a lot of uncertainty. So that is removed by convolutional layers. Okay, here those features will be extracted automatically, but to extract the better and better features, you require large number of layers, large number of filters. So your selection of filters is important, selection of number of layers is important, and based on that, features will be extracted. Okay, so these layers are used for extracting the features, and the last few layers actually, they are fully connected layers, and people use them for extracting for a classification purpose. Okay, like here I want to classify the vehicle, then I can give one input as a car image, then its features will be extracted automatically based on the features. Last layer, this will give a probability that car will have a probability as a 90%, truck will have 5%, fan will have 1%, bicycle will have another 0.5% in this way, if my input image is a car. So this is one iteration. So similarly, thousands of images I will use to train this model. And every time these weights will be updated actually. The weights will be updated based on the error actually. What we'll do during the training phase, we'll give input as a car image and we'll check the probability here. If car is giving 90% probability and others are giving less, then these weights are okay actually. But if car is giving 10% probability, means the classifier is classifying with a 10% confidence and truck is 80%, but our input image is a car image that I know actually during training phase. Then I will compute the error actually here. Based on the error, our back proportion algorithm will be used and the weights will be updated till I get a output as a car actually for this car image. Okay, then I will use another image to test the model. There also I will do this loss calculation and then updating weights. So this process will be continued so that model will become a mature model. Okay. Once it is a mature model, then I will use this for testing purpose for unknown images. And then model will say whether it is a car or truck or van or bicycle. And then I will accept that time. Okay. So these are the training phases, but there are many challenges, many problems. So how to tackle those things we are going to discuss in the coming slide. Okay. So convolutional neural network. So whatever mentioned here, layers actually, that you can write like this actually. So every time there are weights actually, and then like first iteration, this is the first iteration. So x1 is the input, w1 is a weight. So based on this function, we will get the output of that layer. Then we will get that output as an input to the next layer, that is layer number 2. So in the layer number 2, there will be another activation function. So this value and this W2 is the set of parameters. Okay. Then I will get in this way, this whole architecture you can write, okay, in the form of mathematical equation. Okay. So what is convolutional layer? So that is explained here. So we have an input image. So this is the input image. Okay. And we want to extract the features, okay, by using the convolution mask. So we can use the mask size of a 3 by 3. So there can be n such filters. So I have only one input image. I'm going to use a n filters. So let us see how first filter is applied here. So these filters will have the coefficients or simply the numbers. They like, for example, if I want to take the average actually, then I can put all coefficients as a 1, 1, 1. I will, the mask size is a 3 by 3, odd number size I have selected because I want to align this mask. Okay, what is this image? Image size is, for example, 256 by 256. Means there are 256 rows and 256 columns. Okay, and each element of this matrix is called as the pixel. Pixel, this word is derived from the word picture element. Pixel is nothing but the abbreviation of word pixel, picture element. Okay, pix and el from element. Okay, so that number. So I want to, for example, here this the center pixel I want to modify. Okay, using the mask. So I will align like this, and then I will multiply each pixel value, corresponding pixel value, with the weights of this filter or mask. It is also called as a mask. Some people call it as a window. Some people call it as a filter. Okay, so we'll use the word filter. And then if I want to use like a averaging filter, then intensity at this point into the coefficient of the mask, then intensity at this point and coefficient of mask, this point and coefficient of mask, this point into coefficient of mask, such a, and then I will add those. Okay, so that will give a big number. So I can take the averaging. So I will divide by 9. So I will get some number. Although it's a fractional number, but in image processing, people consider integer values as an intensity values. And the range of intensity value is 0 to 255. Means picture will have, gray color picture will have intensity values varying from 0 to 255. 0 means black, completely black, dark, and 255 means completely white. And between these 1, 2, 3, 4 up to 254, all these are the shades actually, towards black or towards white shades. Okay, so this is about the image. So in this way, by applying one mask, I can generate a one feature map or another image actually. There's a problem with the corner pixels. So we can discard actually one row, first row, last row, first column, last column, and we can generate this feature map. Or we can pad 0 outside. There are some techniques, but at this point, let us ignore that for simplicity. And you will get such a yarn feature maps. Okay, so you can see by different masks, we are getting a different features here, different feature maps. This filter, we are getting a blackish image. By this mask, we are getting the edges, large number of edges. Here we are getting edges with some white color, more white color actually with the background. Okay, so these edges corresponds to the considered as a high frequency mask. So this is definitely a high frequency mask. So in this way, I will get a feature map. Okay. So this layer is composed of set of filters, each to be applied to the entire input vector or entire image. Each filter is nothing but the matrix of k by k weights or values. In our case, or in the previous slide, we have used 3 by 3 filter size. Okay. Each filter produces a linear combination of all pixel values in the neighborhood defined by the size of the filter. Okay. So this I have already discussed, so that's why I'll skip this part. There is a concept called as a stride also. Just to help, we can just to reduce the iterations, we can use a stride more than one actually. Stride 2 means we'll modify this pixel and then we'll skip one column, one row, one column, and then we'll jump to the another pixel. We'll skip one pixel in stride 2. In stride 3, we'll skip next 2 pixels. So we'll reduce the operation to save the time actually, computation time. Okay, so that is called as a stride. Okay, then in the neural network we have seen the activation function. So there are various types of activation function. Actually, this neural network concept is borrowed from the human neurons. So any single neuron actually in the brain, human brain, it will have a large number of dendrites, or in other words, dendrites collect the information. Okay, and in the neuron cell, so those EMFs or voltages will be added, and the collective voltage is greater than some threshold, then neuron in the brain will fire. Otherwise, neuron will not fire. So that concept people mimic for the artificial neural network actually. And so whether to decide actually about the firing of the neuron, we need an activation function. So there is a large set of the activation functions. Some of the popular activation function is like a tanh function people use. Then ReLU function they use. ReLU means this type of function. Fx equal to 0 for x greater than 0, x less than 0. And so it is a linear from 0 to this positive axis. Okay, that's why it is called as a rectified linear unit. Okay, so these are the other functions. So let us discuss about the one neuron. As I told, there are dendrites actually which collect the information, but they will collect the information from the previous neuron. So output of the neuron, previous neuron, we call it as a synapse actually. So synapse is the location where information is passed from the one neuron to the another neuron. Dendrite is the lead connecting the input. So anyway, So X0 is the input, and we have a weights here, actually weights based on the synapse. So that's why at the body cell, we will get the product input multiplied by weight W0. Similarly, we'll have W1, X1, W2, X2, etc. At the cell body, all those things will be added actually, Wi into Xi. And just for just controlling the operation, actually, we can use sometimes a bias term, okay. Otherwise, we can discard also at this point. And this is our summation. After that, actually, there is another F is mentioned here. So what is the role of this F? F is the activation function. So whatever sum is there, based on the sum, this activation function will decide actually whether to fire or not. Okay, neuron will be fired or not. So if this summation is sufficiently large, then neuron will be fired. And we will get the output. So this output will be again given to the next neuron. In this way, in our brain, there are millions of neurons and billions of their connections actually. Okay. It's very difficult to mimic by using the hardware or human brain. So at some level, people tried, and that's why we require very high computing machines, okay, to process this data. Just for better understanding, same image is taken here, and we have actually displayed the pictures during the intermediate layers. Okay, so this is the input image, and image size of the input image is 64 by 64. Okay, so it has a 3 channels actually. So we have such a, from this color image, we can generate a 3 images actually. Okay, 3 different colored images. You know, what is the difference between black and white or monochrome image and color image? So color image, we use a 3 channels actually, or 3 matrices for representing. Means for 1 pixel, we will have 3 values, okay, in the color image. So similarly, here there are 3 channels. So color image will separate those channels. That's why red arrow is used here, green arrow is used here, and blue arrow is used here. So RGB, this is a red color channels image. This is a green color, and last one is the blue color. Okay, so we'll apply the 4 filters actually. Okay, 4 different filters of size 5 by 5 into 3. So 4 filters will apply on the red color image. So that's a 1, 2, 3, 4. 4 filters will apply green color and 4 one blue color. So we'll get so many filters here. You can see here. So we'll apply those filters. For each channel, actually, here actually we are collecting RGB and this activation function. Based on that, we'll generate this feature map, 1 feature map. So similarly, we'll get a 4 feature maps. Now, so we don't want to now keep the RGB information. Now we will have another filters, 5 filters. You can see 1, 2, 3, 4, 5. 5 filters on these 4 types of images. So you can see here there are 4 images based on the 4 filters at this level. This first filter applied on these 4 output images. Then second filter applied on this. Third filter applied on this in this way. Then we'll apply activation function. So this is called as a tensor actually, 64 by 64 into 5 tensor. So whatever output images we are getting, those are called as a tensors actually, okay, because they are based on the these filters. Okay. Okay. So these maps are stacked forming a tensor that will be offered as an input to the next layer. So in this way, we will use a large number of layers actually, and we are processing this same information several times. So as a result of that, our model will learn, and model will have capacity to extract the features automatically actually. Because so for getting a good features, we require a large number of layers, we require a large number of filters, and all those things demands for large number of competitions and better hardware, high processing computers actually, okay. Next operation people do between the layers. I will try to show this. Okay, I know. So here you can see this is a car image. Then we have used a convolutional mask with a ReLU as activation function. After that, there's one pooling operation. So through the pooling operation, this size actually is reduced to this size. So pooling operation people use to reduce the size. So how to do this pooling operation? So there are many techniques, simple techniques. You can skip alternate rows and alternate columns. So size will be reduced. Or you can replace a group of pixel by some number, some output number. So we are going to discuss that actually under the head pooling. So there are two types of pooling, even three types also, like a mean pooling is also there. But this max pooling is very popular. And people use this max pooling operation because of many reasons. Here, like this, for our convenience, we have considered a small image of size 4 by 4. And I want to reduce this image size to 2 by 2. So how can I reduce this? One simple technique that alternately I can discard this row, this column, this column, this row, and this row. I will get only 4 values. Okay, but that may not be logical. So that's why people decided to divide the image into this 4 by 4 image into 2 by 2 parts. So this is one part, this is another, and this is another. So for these 4 pixels, actually, we can represent this by 1 pixel. So how to select? So they have selected max pooling. So out of these 4 pixels, maximum value is selected and written here. Out of these 4, 30 is selected. Out of these 4, 112 is selected. And out of these 4, 37 is selected. So this is the max pooling operation, okay. Or otherwise you can go for the average pooling. So you can take the average of these 4 pixels and write here. One limitation of the average pooling is that you will get a fractional number and competitions will also increase, okay. But anyway, both are popular. People use these 2 operations just to reduce the size of the image. We can reduce the size of image by half actually, half means 1/4 actually. You can see here. So 4 by 4, now it's a 2 by 2. So only 1/4. Okay. So this operation downsamples the image in order to reduce the spatial dimensionality. It reduces the size of the data. Okay. Secondly, by reducing the image size, it is possible to obtain the kind of multi-resolution filter bank actually. Okay. So these are the 2 advantages. Next is the normalization. So normalization is done to eliminate condition of underfitting and overfitting which occurs due to maximum bias or maximum variance. So how they apply this normalization? So by subtracting the mean and normalizing the standard deviation to unity. So if there are 4 samples, for example, like in the previous case, these samples, so we can compute the average as a 13. We subtract this 13 from each number actually, okay, and we'll replace here itself. So that is averaging. That is the normalization operation. So this is also one of the popular operation. What is the output of this, or what we'll gain actually by applying normalization? We will get about the features. That features are less correlated with each other since we are removing the mean from all samples, okay. And the features will have same variance, okay. All these things are possible by the normalization. Then fully connected layer, last few layers are the fully connected layers, and they are used for the classification purpose. If last layer output is 4 by 4 into 40 tensor, okay, Then what we'll do, instead of writing 4 by 4 into 40, here meaning is that we have 4 by 4 images and we applied 40 filters, then we'll get a 4 by 4 into 40 tensor, okay, in that layer. So instead of writing that, we'll write is a 1 into 640. So we are converting the matrix into the vector form. How we are considering? Just only we are concatenating the each row actually, generating the one array. Okay. So it is called as a fully connected layers. So you can see in this diagram. So X is equal to Z1, Z2, Z3, Zk. These are the weights W1, Wk, and this is the input. Okay. So here we'll get Z1, Z2, Z3, Z4, Zk as a product of these two vectors. One is the W1 transpose, W2 transpose. So weight vector, this is weight vector. This is the input samples, and we'll get ZJ. Once we get the ZJ, then we can use the activation function to select. Okay, so people are using softmax here, and then we'll get the output. So here, as output, we'll get the probabilities. This is a green color or output of first neuron. So here the probability is more than blue, then purple and red color as a least probability. So depending on the probability, actually, that object is classified. So as if here a green object has the highest probability. In this way, people use this for computing for a classification purpose. Okay, we need to update the weights actually. So how to update the weight? So people calculate the loss actually, or loss. Okay, and the function used to calculate loss is called as loss function or cost function. So these are the cost function. So here they use a cross entropy loss function. So this is a CNN, with CNN layers. Then we have SI, and then by applying the activation function, this is becoming FSI. I is varying from 1 to C. So what is 1 to C? That is the index of each neuron. So there are C neurons in the output layer. And then we'll compute the CA. Okay, that is the loss for the particular neuron. You collect that, so that will give the total loss. So based on the loss, we'll update the weights of this CNN. Okay, so that is the philosophy in the deep neural network. Okay, another term is commonly used. It is called as a regularization term. So in regularization, what people do, they add a new term actually to penalize the undecided situation, which is called regularization. Okay, something is added actually in this weight actually. So sometimes they add L1 norm is mod values of the weights multiplied by lambda, or L2 norm means we are taking the weights square actually. Okay. So in this way, regulation is performed. There's a possible problem with using only the loss function as presented. This is because there might be a many similar W for which the model is able to correctly classify the training set. So there may be many W values. So to avoid that, if we add something like this, some norm values, then we'll get a unique solution or less number of W's having the maximum classification accuracy. Okay, so that's why we can perform the operation on the weights directly and add into this regulation function. It is called as a L1 regulation on least square, and second equation is the L2 regularization. Okay. And then training of CNN. So here we have to give some initial values or initial weights actually to the model. So for selection of initial weight, people use many criteria. One of the easiest strategies is one can use a Gaussian distribution. To produce the random numbers, and these numbers act as the weights, and then we'll check the probability of the output neurons. Based on that, we'll again train the model. Okay, so this is the, so that's why this initialization is important. Also, people use dropout layers actually. This is to avoid overfitting of the model, because if we give a good cases or very good example, good pictures to the model for during training purpose, and while testing purpose we don't have same quality picture, we have the noisy pictures, then model will not classify that. Okay, but our requirement is that we want to classify those noisy pictures also, or some small error picture also. So that's why we have to train the model with those noisy situations actually, and these situations are occurring during testing phase, and we are not sure about the training phase actually. So we don't have bad quality images for the training purpose. So that's why to introduce some randomness, something to mimic the testing scenario, people use the dropout layer. They drop some neurons, they drop some layers, and that too not every time, during every phase they drop. So during the first iteration, they may drop layer number 3 and neuron number 5. So next time during iteration 2, so those neurons will be placed as it is, and now we will remove some neurons from the layer number 5 in this way. So there also we can introduce the randomness, randomly removing layers or randomly removing the neurons. It is called as a dropout layers. And people have observed that by performing this type of operations, actually, models are giving very good accuracy. Okay. Okay. Next is about the batch normalization. So how to normalize the batch? So people train the model actually with the batches actually. They will give a batch of 10 images or batch of 100 images during the first phase. Okay. So there actually batch normalization is we will remove mean from the all samples actually. Okay. So that will help actually to regularize the model. Okay. Okay. Then there is another very good term called as a transfer learning. So as the name indicates, we have already trained one model for one application. We want to use same model for some other applications. Like we have trained the model for vehicle classification, and we want to use this model for agriculture purpose, like for classifying the weeds or classifying the fruits, for example, classifying the leaves, different leaves of the plants. Okay. So we want to use that for that purpose. So there we'll use this already trained model with some modification or with some twinning. So that technique is called as a transfer learning. Okay. So there are two types. We can via feature extraction or via fine tuning. So we'll see this, or if somebody has questions, we'll discuss those questions. Okay. So what is a traditional machine learning and what is a transfer machine learning? Transfer learning. So in traditional learning, what we are going to do, we have one model for one application like vehicle classification application. So we have that data set. So we have trained that model. And now we are going to give a new images, okay, or unknown images for testing purpose. So this model is working fine. Okay, we have another application. So another data set of the plant, leaves of the plants, okay, tomato leaves, then cotton leaves, okay, leaves of the cotton plant, leaves of the tomato plant, okay, leaves of the wheat, okay, leaves of the jar, okay, such a database we have, and we are going to ask our model to classify them. So these two different models we are using here. But in transfer learning, we have already developed one model for vehicle classification. And we don't have time actually to train the another model. We don't have resources also to train such a big model. even we don't have such a bigger data set or so, then what we'll do, we'll use this already trained model. And by doing some cosmetic changes, some small changes in the model, okay, we'll use for classification of the plants. And people have observed that they're getting a lot of benefits actually by using already developed the model. But there are risks also that all models will not work for all problems. So that's why proper tuning is required. So it's very subjective. We'll discuss that also. Okay. So as I mentioned, this CNN model is very popular. Okay. But if data is a sequential actually, or there is a time varying signal, like a sentence, like in a natural language processing. So natural language processing, we want to process the sentence. We want to predict we have to predict the next word in the sentence. Okay. Like I love India. This is one sentence. So this India word I have to predict. So it is based on the previous 2 words or previous 4 words, 5 words. Okay. So this is a time varying signal. So there people use this residual neural network. We are going to see that. Okay. So this ILS VRC, this competition was very important actually, because through that competition, deep learning become very popular actually. Since 2011, this competition started, and they started on the ImageNet dataset. And that's why the name is ImageNet Large Scale Video Recognition Competition. And every time people come up with the new model actually. Okay. So with a large number of layers. Okay. So lastly means maybe in 2015 actually, VGGNet was the winner of that competition. Okay. And they proposed the model with the 152 layers and error reduced to 3.57%. You can see very small error, but we have to pay the cost in terms of layers, 152 layers. Before that, many people, many groups like Facebook, then other groups also, they won the competition, but model was not such a deep. Okay. And there are other data sets also which are easily available, like COCO data sets also popular. Okay. This is about the objects, various objects actually COCO data set has. Okay. So deep CNN versus ResNet. So these CNN models are good for the low, mid, or high level features. Okay. So deep CNN contains 60 to 30 layers and has a great significance in visual recognition task. Okay. In the ResNet, actually, you can see, so there are layers, weights, etc. But if you have a large number of layers, then there are chances that you will lose the features or lose the importance of the original image. So that's why after some time, the input layer, that is also fade here. There was a vanishing gradient problem. To address that, actually, ResNet was evolved. Okay. So we will not discuss much about the ResNet, just I want to give the insight actually. So you can see this is a plain network, so many layers, 512 layers, you can see here, so many layers are there. Then actually what ResNet has done, this is the input, then input, after some time input is again fade, after some time input is fade. So that actually dependence of the input will be there actually. And people have observed that this has given a very good results. Okay. So vanishing gradient problem is not there. So you can see this is a smaller network. Okay. Another advantage is the recurrent neural network is RNN. Okay. So that we have 3 inputs, xt, xt minus 1, xt minus 2. When I'm giving xt minus 2, I'm getting output as a y t minus 1. Whenever I'm giving x t minus 1, I'm getting output as a y t minus 1. Whenever I'm giving x of t, means current time, I will get the output y. So this is okay actually. In the normal CNN model or feed forward model was okay. But what recurrent neural network has done, they have introduced actually, they are using the previous output for commenting about the present output. So we want to compute a y of t, that is our objective at this point. But while computing the y of t, we are using the x of t, that is okay. But previous output also I'm using, that is y of t minus 1. So this output y depends on not only on the current input, but depends on the previous input also, previous output also. So in an NLP, like here, the first word, second word is there. So for predicting this current word, we are using the current input as well as the previous output, which previous word, then previous word. In this way, there will be link. And that's why it helps for processing the time series data. So RNN can look back in the time and use the previous output as the additional input for improvement. And the better version of the RNN is called as LSTM, long short-term memory network. Okay, it is called as a long short-term memory network. So in our brain also, we use the information, short information as well as long information. Okay. So present, like I'm current information and previous information also we store in the brain, and that's why our decision is very mature decision. Okay. Okay. Like I want to book the train ticket, and I don't know the whether my ticket will be confirmed or not. Okay. So for that time, for that purpose, I will use the current information. Okay. And I have previous experiences also stored in my data, my brain. Okay. So I'm using both information to plan my current journey. So in this way, these RNNs are helpful. So here ultimate goal is to mimic our human brain, whatever logic or whatever processing we are doing in the brain, people wanted to reflect in the models. Okay. They are not successful that much, but even if we are able to solve some problems in the real world for decision making, then that is also enough. Okay, that is also good. So this is there. So this is RNN. So we are giving the input, but we are giving the previous hidden layers output also to predict the current output. And then this hidden layers output will go for next function. So next input, again we are going to talk about something. So in this way. So no matter how long the input output sequence is, we only need one function f, this function, and the f's are different actually because they are not only depend on the input, they are depend on the previous output also. Okay. You can make it deep also. So if you are f1 and f2, such a layers actually, then it becomes very complicated. Okay. And in LSTM, same thing is used here. So they use a different gates actually. So this gate is called as the forgot gate. So these are the inputs actually at different instance. This is the current input, next out input, previous input, etc. And for getting the current output actually here, we are using the previous output also. So I will not go into detail of all this LSTM. So output gate controls when goes into output. So here in LSTM, sigmoid or tanh function is used. Sigmoid is mostly used as a, you can see. So here tanh is used, and these are the sigmoid functions. So this sigmoid function is used as a switch actually. When this switch is open, then we are not using the forget gate actually. We are, this information is passed to this gate actually, okay? Input gate, and decision will be taken. If this switch is open, then we are using the input gate. We are not using forget gate in this way. So people use this feed forward network and recurrent network. You can see the difference. So here simply we are giving input, we are getting output. Again, we are giving this output as input to the next layer. Again, we are getting the output in this way. Finally, we will get the Y. But in RNN or LSTM, whatever, so here we are giving input here, and this is some initialization. Then for the second input, so this X1, X2, X3, these are the elements of this X actually. Okay. And these are the hidden nodes. So in this way, you can write the change in the equation, this equation. So here we are writing a t minus 1 as well as x of t to compute a of t. So this is little complicated. And we can compare RNN and LSTM also. So here simply output is given as input here. But here they are storing actually in the memory cell, this output also somewhere. And then they are reusing. Okay, so there are many applications people use as a chatbot, then email, text autocomplete. Even whenever you are writing the words actually, writing the message on the WhatsApp or on the text actually, sometimes they sometimes you feel the or suggest the next word actually. Model suggests the next word. So that is because of this RNN and LSTM actually. So that type of network is involved there. So that helping you to write the message, okay, on the WhatsApp. Like even LinkedIn also they give suggestions actually. Where is small text. Like if you want to congratulate something, somebody has congratulated you, you want to say the thank you, or so that type of messages, okay, people use. So chat bots are also there. Image captioning, we can convert image to text, or we can describe the image for a blind person, okay. So there are many applications. Okay. So here is one example of image caption generation. So we can divide the image, and for each segment we can have filter, and you can get some weights, okay. So initialization, Z0. So, and then based on these weights actually. So these weights, there are more weights for these filters, 0 for others. So we can consider this as attention to a region. Based on that, we can describe the image. This image we want to describe. So this is the first word we are talking about, this image. So this word may be the girl actually. Okay. Then we want to predict the next word, and that word may be the banana. Okay. So here actually these filters are giving you the results, like these two regions, region 1 and region 2. They are giving the highest response, others are at 0. So in this way we can predict the level actually. This attention mechanism actually is becoming nowadays very popular in this deep learning area. You can see here, woman throwing a frisbee in a park. So for this image, they have generated the motion-based attention, and you can see here, so that frisbee is the attention. That is important for this video or for this image. Phrase B. Here, dog standing on a doorwood floor. Okay, this dog actually. In this picture, there is a dog. So this dog actually with some different features we can extract attention. Here, this stop symbol is important. So it is a part of attention. Here, face is a part of attention. Here, the crowd is a part of attention. People sitting in the boat. Here, giraffe is the attention actually. Background, we are not much interested, okay? Though there is a tree background. So giraffe standing in the forest with the trees in the background. So attention based also we can label the image. So these are some of the applications. So thank you. Any question? Hello?
Hello, sir.
So if you want to ask me any question, then I will
Okay,
answer, and then
okay, sir. Dear participant,
we will
if you
give
have
some
any
break.
queries,
Should
if
we
you have
give
any
a
queries,
break for 5 to 10 minutes, and then I will discuss your
okay.
next application.
Dear participant, do you have any queries?
You can write query in the chat box also if you want.
Yeah, also.
Hello?
Sir, after 5 minutes, you start the session, sir.
Hello?
Hello, sir.
Huh?
The session is over, sir. Still is remaining.
No, not over. I have some other slides also. Because I want to talk something about agriculture, no? Because
Yeah,
theme
yes,
of our
sir.
workshop is agriculture.
Okay, okay, sir. You
Should I
start this.
explain that also immediately, or should we take break?
Okay, sir. You start the session, sir.
Let us go for okay, because okay. So now I will share next PPT.
Bujamma.
Hello.
Sir.
Hello.
Start.
PPTs are visible?
Yes, sir. Visible, sir. Visible.
Okay. Just so now we will discuss Some applications of deep learning in agriculture domain. Okay. So already I have discussed this deep learning. Okay. So deep learning is a subset of machine learning, and machine learning is a subset of AI that we have seen. So this was the initially artificial intelligence, artificial neural network was introduced. So input layer, output layer, and these are the neurons. These are the output neurons, and in between many hidden layers. Okay. So deep neural network means there, if you introduce more and more layers in between, the network becomes a deep neural network. Okay. And CNN is one of the important network because that helps for extracting the features. Okay. Widely used for image and object recognition. So we are going to see the applications related to object recognition from agriculture domain. This is a very general diagram. You can see here input image is a zebra, and we want to classify that. Okay. So here we have used convolutional layers, then convolutional layer to extract the features, and then pooling layer to reduce the size of the this tensor, and then flattened layers means everything we put in the vector form. And all these are the fully connected layers. We have used softmax activation function, and then these are the probabilities. So zebra is predicted with a 0.7%, 70% probability. So then it's okay. Actually, we will modify the weights little bit, not much, during the training phase. So this is there. RNA also I introduced little bit. So there are various applications in the agriculture domain. So few applications which I come across is the identification of weeds. Weeds means unwanted actually grass between the plants. So it is called as a weeds. So there are various types. So we want to remove that so that our plant will grow and not weed. Okay. Then another is a tomato leaf disease detection. So most of the diseases actually we can recognize based on the pictures of the leaf. Okay, so that also we are going to discuss. Identification of the water stress. This is very common problem in our country, that for some region there is a heavy raining, some region there is no raining. So because of that, actually, some plants get a lot of water. They are even, sometimes there is a excess water, or sometimes there is a lack of water. So it is called as a water stress. So how to identify and how to address the, how to detect this, and once detected, we can supply the water to those regions, okay, or remove water from those fields also, okay, if there is excess water, okay. And next is the weather forecasting, and then fruit countings. So I have listed here 5 applications, and I use some good papers in these real applications, okay. So weed. So for weeds also, so we have collected from literature. So there are 2,50,000 plant species. Means based on the leaves, if you want to classify, then there will be 2,50,000 plants, okay. And 250 species of the weeds actually. And our aim is to remove the weed plants, okay, automatically, or we can, or levers can remove the weeds, okay. So further purpose, people use this image based, actually, image and deep learning based identification of the weeds, okay. So you can see here different. So these are the plants actually, and there are the weed actually. Okay. So that we want to classify into different types. Okay. So this LSTM, CNN, I have already explained you. One of the paper actually I have referred here. So they have used this model. You can also suggest your own model. Most of time people work with the trial and error actually. So you can write a program in the Python, develop some architecture, and then you train with some images, known images, see the results. Based on the results, model will update their weights, and some point of time model will converge actually. Model will start giving same result. If input is the type 1 image, then you will get output as also a type 1 weed. Okay. So people are using this. So few researchers have used this type of weeds: Chini, apple, W1, Latna, Parkinsonia. So these are the types of the weeds. They have different color, texture. Okay. So you have to give that data during the training phase to the model, and we want to classify. Okay. So these are the reference papers for that purpose. So I saw these papers where they tried for using a deep learning or machine learning approaches for weed classification. So once we classify the weed, then we can remove the weed by using some technique. Okay, some other technique. So here we want a good accuracy. Otherwise, we should not remove the plants actually. Okay. So there should not be misclassification. Plant should not be classified as a weed, and weed should not be classified as a plant. So based on that, actually, we can develop the algorithm. Okay. So here we need a large number of database. So availability of database is a problem, but you can even generate own database for your particular field actually. Okay. The next is a plant disease diagnosis. So we can detect the disease, and we can pesticide also. Can use the pesticide to remove those problems or remove the disease. Okay. We can use a drone or other technology to remove these bacteria affected leaves and other things. Okay. So there's work actually. People use machine learning algorithms such as SVM, and they got accuracy up to 94%. Okay. So I saw many paper on tomato leaf disease detection. So I have listed in the references, so you can go through if you want. So farmers from poor countries usually observe their plants through naked eye, which is a time consuming and inefficient. You cannot go visit a plant, every plant actually, to check the disease. Okay. So instead of that, we can take the picture of your field. So here aerial pictures means pictures can be captured by drone, or pictures can be captured by satellite, but drone is okay. Or some fixed camera near the field. And based on the leaves images, we can identify the disease, and so treatment can be given accordingly. Also, we can identify the percentage of the disease, how many leaves are affected, how many plants are affected in the field. Based on that, we can plan the pesticides and other treatment. So that's why these automated techniques are very helpful. Okay, and people are using this. So there are papers. So here we have to use image processing techniques to capture the image and remove the noise. And once we have pre-processed those images, we can give those images to the deep neural network for classification purpose or disease detection purpose. So there is a lot of work. So there is nothing special actually. You can propose a model based on your leap and your problem, okay? And based on the available hardware also. So this is one domain. People use a transfer learning, that also I mentioned in the previous slide. That transfer learning means already trained model we can use for reuse for solving our problem. Okay. So this is one architecture. They use the GoogleNet architecture, VGG16 model. This VGG16 here, word 16 is used to represent the number of hidden layers. So they contain 16 hidden layers. So you can see here input image is this. Its features will be extracted by these convolutional layers. We are going to use the max pooling layer to remove the dimensionality, and fully connected layers are used, last layers, to classify these leaf actually. Okay, so the leaf can be classified as a healthy leaf, bacterial leaf, early blight, and late blight leaf. So in the 4 classes. And if a leaf is healthy, we have I have calculated some samples, for example, from the field. If there are 10 leaves and all leaves are healthy, then I can say actually that there is a less disease, okay, in the field. So no need of the pesticide and other things, okay. But if I found many out of these 10 leaves, I found 8 leaves with the bacterial, then I can say, so there is a large infection, okay, in this way. So in this way, people use this VGG16 and GoogleNet architecture for this purpose. So you can see this is the leaf, and these are the diseases actually, okay. These are the mostly tomato leaves and different types of disease based on the different color. We can comment, okay. Here you can see a black part, here you can see blue color. So based on the leaf, we can take the decision, okay. So these are the reference papers. If you want, you can use these references for the disease. Another problem is called as a water stress problem. For that purpose also we can use deep learning, but here we cannot use a simple images. We want to use aerial images, okay. So here you can see here image D, lot of water is there in the banana plants, okay. So that also destroy, okay, banana trees, excess water. And here you can see the plants are actually dying, okay, because there is no water, okay. All plants are becoming brown actually, okay. Plant should be green actually, tree leaves should be green actually, but here you can see the leaves of the brown color. So that's the problem. Here there is a need of water, and here there is excess need. So it is called as a water stress, okay. So this we can notice actually, you can identify by using aerial images or drone images, okay. So we require drones for that purpose. Weather forecasting also another application. There we can use a satellite images also, okay. We can have people have developed the machinery for pesticides actually, okay. This is a sensor based actually, so there are sensors, they collect the information. So in this type of devices also people use the intelligence, okay, deep neural network or artificial intelligence techniques. Another application is the fruit counting. So you can see here number of fruits. So we can comment about the yield actually, this year's yield, previous year's yield. Also we can decide actually whether crop is at the final stage to remove the fruits, okay, all those things. So in the conclusion, I would like to say that there is a lot of scope for deep learning and image processing based techniques in the agriculture domain. Comparatively less work is observed in this region, in this domain. So I hope that there is a lot of scope for deep learning experts or AI experts in the agriculture field. So thank you. Anybody has any question they can ask?
Hello.
Hello.
Hello. Okay, dear
Any
participant,
question?
if you have any queries, please ask. Or you communicate with chat box.
Okay, is there any question?
So dear participant, please ask if you have any question. Or you raise hand, so we will unmute. Okay,
Okay.
if you don't any ask, if you don't have any queries, so we will give the vote of thanks for this, sir.
You can send me query by mail also in future if you don't have query now. I'm writing my mail ID. And my mobile number also. This is my WhatsApp number. You can send query by WhatsApp also. So I think we have discussed enough basics of the deep learning and few applications of the deep learning for agriculture domain.
Hello, Rasegna madam.
Yes, sir.
Okay, so please give this small summary of this session and also vote of thank.
Okay, sir. Thank you, sir.
So I think we should stop here. Razgane madam.
Sir?
I have completed my presentation.
Okay, sir.
So I think if there is no question, then we can stop.
Yes, sir. So we'll end the session with a vote of thanks, sir. It will take only 2 to 3 minutes, sir.
Okay, no problem. Go ahead.
It has been such an honor to be a part of this wonderful event. I would like to thank our Honorable Chairman, Sri C.H. Mallareddy Garu, and our Principal, Dr. A. Ramaswamy Reddy Garu, and also Atal FTP sponsored by AICTE. On behalf of all the participants, I would like to extend my heartfelt gratitude to our esteemed Chief Guest, Dr. Chunduri Sarada Ma'am and Dr. Mahesh Kumar H. Kolekar, sir. The topics which you have covered in this inauguration session is an informative and catchy for all the participants. And also, I would like to sincerely thank all the heads of the various departments and deans who participated in the event throughout. A wide round of applause and thanks to all the participants who made the event successful. Finally, I would like to thank all of you present here for making the time to be with us today and helping us making this event a grand success. Thank you, one and all.
Thank you, Rasegna madam.
Thank you, sir.
Okay, thank you. So should I leave the meeting?
Yeah, yes, sir. You can, sir.
Okay, thank you. Bye.
Okay. So, dear participants, we will meet by tomorrow, the same time at 7 o'clock.
Okay, sir.
Okay, sir.
Dear participant.
Okay, sir. Thank you.
So attendance we will update sir in portal. So don't worry regarding attendance.